On August 6, 2025, there was a glimmer of hope. A moment so quiet, so sterile in a lab, and yet so deeply unsettling in its implications. The James Webb Space Telescope, the most potent observatory in human history, was forced into emergency override mode. Not for a supernova, which is not a black hole but rather something far more local and far more terrifying. Or at least a comet, something that looked like one designated C3I Atlas. It was first assumed to be another interstellar wanderer, cold, silent, and predictable. But when Webb sensors locked on and the first wave of data poured in, what they captured wasn't just unexpected, it was impossible. Its chemical fingerprint revealed didn't fit any natural model. The ratios were grotesque, the elements mismatched, the behavior erratic, and as one feared, as the numbers kept coming in, a stealthily progressing dread began to progress through the minds of every astrophysicist watching the feed. What if this isn't a comet at all? What if this is something sent? The first sign that something was terribly wrong came from the comet's coma, the bright envelope of gas surrounding the core of it. Normally, at this distance, 6 astronomical units from the sun, a comet should be asleep, frozen, inert. The sunlight out there is weak, too feeble to cause any meaningful outgassing. But C3I Atlas was already active, violently so. James Webb picked up spectral lines dominated not by water vapor as expected, but by carbon dioxide. A lot of it, 8 times as much as water. That ratio 8:1 was not just unusual. It was unheard of. Typical comets barely reached 0.7. Even Borisov, the final interstellar visitor, hovered at roughly 0.5. This was something else. A body spewing carbon dioxide at a rate that couldn't be explained by temperature or solar proximity. It was as if the object had been designed to vent this exact compound in circumstances where nature wouldn't let it happen. Even stranger, the thin, ghostly coma. There was almost no dust, no solid debris, no typical chaos, just gas. Smooth, controlled, and highly specific gas emissions that hinted at a different kind of chemistry. One that is unrelated to how we know about comets' formation. As the Webb telescope locked in deeper, the story turned darker. Its sensors picked up something even more disturbing over gas: nickel. Strong, consistent nickel spectral lines started appearing across the ultraviolet and near-infrared bands. Not traces, not anomalies, but powerful signals, clear, repetitive, and real. Nickel lines stacked perfectly above the background, rising in concentration the closer the object came. At 3.8 astronomical units, the output was already measuring above 10 to the 21st atoms per second. By 285 astronomical units, it had gone up by an entire order of magnitude. But the shock wasn't the presence of nickel. It was what was missing: iron. All around, instruments from Webb to the Very Large Telescope to Gemini. Iron was absent, flat, dead. No signal, no trace, not even noise, and that is unusual. In every meteorite and natural comet ever recorded, nickel and iron are partners. 1 part nickel to 15 parts iron consistently, up until now. C3I Atlas broke this rule in the most violent way possible. Nickel overtook iron in weight by more than 40-1. There's no known natural process that can create such a split. In labs, energy is needed to separate these metals, machinery, intent. And here a thing moved quietly through space, doing it passively, or maybe not completely passively. Prior to the emergence of the chemical signatures fully decoded, something else caught the eye of the Pan-STARRS tracking network. C3I Atlas was accelerating, but not like a comet would, not from solar heating or pressure. It was too far from the sun, too cold for sublimation jets to generate that much momentum. Even so, over the span of just 72 hours, the object's velocity increased by 0.12 ms squared. That number may sound small, but for a body 11 km wide, the size of a city, that kind of acceleration is immense, like witnessing a cruise ship choosing up speed in the middle of a dead calm ocean without engines. The change wasn't smooth either. The analysts observed jumps, jittery flickers layered over the principal motion arc, as if something inside the object was turning on and off and so forth. Attempts to explain it through fractured crusts, outgassing, or solar winds failed. None could match the rhythm. None could explain the regularity. Every 7.2 hours, the 3I Atlas became brighter, sharply, predictably, like a lighthouse. The brightness curve wasn't chaotic, like falling objects. It was locked clockwork. Some suggested a sheet-like surface catching sunlight, Others proposed a rotating hollow frame. But one thing was clear, there was no rock here. It was something moving with precision. And here's where the science begins to tremble. Because when everything is ruled out, when sublimation, randomness, and a jumbled structure all fail, what remains is a possibility no one wants to face. That C3I Atlas is engineered, manufactured, built, perhaps not by intention. It could be debris, a fragment, a derelict vessel from a civilization that died before Earth grew forests. However, it could be worse, something vivacious. Still active, a probe mechanism still responding. A system that sees us and doesn't care, one that follows a trajectory not set by nature but by design. Because no comet should emit, wake up in the deep freeze, metallic nickel without iron, accelerate without fuel, and spin with mechanical rhythm. And yet here it is, doing all of that in front of the instruments we use best with no effort to hide. The James Webb override wasn't just a technical reaction. It was a whisper of panic, an unspoken agreement that this isn't normal, that it could be the first time we're looking directly at alien machinery. And even if we're wrong, the simple fact that we can't tell the distinction any longer, and that alone is the warning. As the acceleration data sparked debate across observatories, a new stream of information emerged, one that was even harder to dismiss as natural: the light curve. Data on photometry from Gemini South and the TEST Space Telescope revealed a periodic brightening of C3I Atlas every 7.2 hours. That alone would not be too unusual. Many comets and asteroids tumble and reflect sunlight in repeating patterns. However, this was not a chaotic tumble. The brightness spikes were too clean, too exact. They weren't flickering irregularly or gradually like the rotation of an erratic rock. They appeared and vanished like a beacon, on and off in perfect intervals. Even though gas emissions went up and the thing accelerated, this light rhythm didn't change. It held its cycle like a metronome. This equilibrium suggested something far more structured. Something that was responding to more than just sunlight randomly, but reacting with precision. Some theorized it could be a light sail, a structure with a lot of reflection intended to capture light from the sun. Such a system could theoretically account for both acceleration, in addition to the frequent flashing pattern. Others proposed a rotating platform with flat panels, but all agreed. The behavior didn't match any established natural object. This wasn't a spin. It was a signal, a mechanical pulse. And with every pass it whispered the same message to the instruments watching from Earth: I am not what you think I am. The moment everything shifted came not from the object itself, but from the people observing it. On August the 6th at 2:11 GMT, ground-based observatories sent an alert to the Webb Control Center. The spectral data pouring in from other telescopes couldn't be ignored. CO2 emissions off the charts, metallic readings spiking, and a sudden velocity curve that was unrelated to gravity. That's when it happened. The emergency override, an extremely rare protocol that interrupts every scheduled James Webb Space Telescope from the perspective of its mission to investigate a single anomaly. It is a move that wastes valuable time, fuel, and budget, and it's only been performed a few times since the telescope was launched, and never before for an interstellar object. Within minutes, the override chain climbed past project timelines and committees and landed directly on the desk of the scientist for the project. The authorization had to be unanimous, and it was. The Webb pivoted, its instruments recalibrated, and it locked onto C3I Atlas at 2:17 GMT, utilizing the NIR spec instrument. What came down in those first packets of data wasn't just bizarre, it was historic. The spectra didn't show the icy fingerprint of a comet. They demonstrated a carbon chemistry extreme. It was so volatile that it altered every known solar system body look tame. The decision to overrule was not simply a scientific choice. It was a silent alarm. The most advanced telescope ever built had just paused the cosmos to follow a machine. The more scientists investigated Webb's data, the more difficult it was to locate anything familiar. The carbon dioxide to water ratio was completely out of line, but it was the metal profile that tore the book of rules apart. Every comet has, every asteroid, every meteorite ever studied. Iron and nickel travel together. They come from the same place. Stellar fusions held together by physics and fused in ancient explosions. The ratio could be slightly different, but the partnership is unalterable. Not here. In C3I Atlas, nickel was everywhere and iron was gone. Not reduced, not masked, gone. All checks returned clean results. The teams of ultraviolet spectrographs cross-referenced over a dozen known iron lines. None appeared. Nickel, by contrast, the spectrum was illuminated like a floodlight. Wavelength stacking at 3415, 3524, 3169 angstroms and more, clear above the noise. The only process known to be capable of such separation in a lab involves high-energy chemistry, industrial pressures, and precise control. The group offered one explanation: the inclusion of nickel carbonyl, a volatile compound that vaporizes at just 43 degrees. But even this molecule is rare, and it does not account for the complete absence of iron. The result was a spectral fingerprint that didn't match anything natural. No one, not even Borisov or Oumuamua. It did not match at all. A compound composition so skewed, so deliberate, that even the most conservative voices started asking, what kind of location, what kind of world, or what kind of technology could create this? The strangest part of this unfolding mystery doesn't come from deep space. It comes from Earth, in museums, in tombs, in ancient texts that speak of iron from the air. It was known to Egyptians as metal of heaven. Kings buried the blade. Nickel is nearly 11% in Tutankhamun. Impossible to forge with ancient tools, but perfectly match the chemical meteorite fingerprints. Babylonian scribes wrote of falling stars and burning stones, always paired with omens of war and destruction. Across the ancient Near East, elite artifacts, rings, beads, daggers, appear crafted from metals richer in nickel than any earth ore, fallen metals, which flashed and that inspired awe and fear alike. And now, in 2025, we're watching the sky again and seeing the same signature. High nickel, no iron, no known source. The Widmanstetten pattern, the crystal banding that is unique to space-formed metal etched into relics older than urban areas. Historians and physicists alike now ask the question no one ever dared. What if those artifacts went beyond meteorite fragments, but evidence of contact? What if those metals were not just debris from the stars, but fragments of something that had come before and had already passed by? And what if C3I Atlas isn't just the next anomaly, but the following section of a very old book that we have only just begun to read? As scientists continued analyzing the high nickel exhaust and CO2-rich emissions, a researcher at Caltech discovered something troubling concealed in the temperature data. Buried in the glow patterns from C3I Atlas was a subtle but consistent electromagnetic rhythm, a frequency. The pulse was too often to be random, yet too faint to be an intentional broadcast. The Webb sensors had recorded it, but at first ignored it as noise from instrumentation. It didn't. When sonified emission data were used, converted to audible waveforms, it revealed a repeating beat. Not music, not language, but something even more chilling. A mathematical cadence. Prime intervals, Fibonacci ratios, geometric harmonics that echoed structures found in DNA and crystal growth. In the design of historic architecture, the message was insufficient to transmit across space, but sufficiently powerful to be read by any observer nearby. That is to say, it was like a cosmic breadcrumb trail, a fingerprint that is not embedded in radio waves but in the behavior of the object itself. And if we could hear it, others could too. The question wasn't who the signal was aimed at. The question was who else has heard it already. Only days after the Webb override triggered global attention, geophysicists began identifying Earth's anomalies in the southern hemisphere magnetic field. At first dismissed as fluctuations caused by minor solar activity, it became more difficult to